Hi, good morning, everybody. Myself Sujata Kumar, studying in Kadeshwar College of Engineering, Bangalore. And my class is Telugu, and my subject is Introduction to Civil Engineering, and my subject code is ESCK104A, and my credit studying in second sem. Now coming to my new topic is about civil engineering second video segment is uh, speaking about centroid problem in civil engineering. And first of all, let us study what is about centroid in civil engineering with an example. What is centroid? Centroid means is a geometrical center of geometric object, and one-dimensional curve, a two-dimensional area, or a three-dimensional value. Centroids are useful for many situations in statistics and subsequent courses, including the analysis of distributed forces, beam bending, and shaft torques. And now let us discuss about the properties of centroid. It is located at the point of intersections of the medians. Centroids always divides the median internally in the ratio of 2:1 from the vertex. Now, centroid divides the triangle into three parts of equal areas. Not only triangle, it depends on the any certain objects like a square, rectangle, semicircle, and pyramids. Okay, in certain uh, civil areas. Okay. Now, the last point is about the center of triangle always lies inside the triangle. This is an example of a particular civil engineering that I took is about triangle. And so there are so many examples for centroid for like a rectangle, circle, semicircle. We can take that also example for centroid. Now coming to the geometrical figure, these are the geometrical some important figures about centroids. Now coming to shape is rectangle and triangle and right angle triangle circle and semicircle. Now it's about the area, and the area is pi by 2 and b into d. Triangle is half into base into white. Right angle triangle is half into base into side. Circle is pi r square. And circle is pi r square by 2. Now x bar and y bar. In triangle x bar is b by 2 and y bar is b by 2. In triangle x bar is b by 2 and y bar is 1 by I by 3. In right angle triangle 1 by 3 by b, and then y bar 1 by 3. Circle x x bar is equal to x into y bar is equal to r. Similarly, in semicircle also x bar is equal to d by 2, and in y bar 4r by 3 pi. Now let us find out the problems on centroid. How to solve the problems in centroid? Tips to solve problems. Number one, the centroid always lies on the symmetrical axis. You know the central lies in symmetrical axis. And second one is the identical the symmetrical axis. If any, choose them on the reference axis. If no symmetrical axis is available, choose the left and bottom corner of the given figure as the origin. The center figure lies in the first quadrant to avoid negative centroid values. Look at the second statement is identify symmetrical axis. Means let's first we have to find the symmetrical axis. Then we have to choose the excuse me choose the reference axis. If there is no symmetrical axis available, like in figure there is no symmetrical axis is available in figure. You have to choose the left and bottom of the corner in the given figure as the origin. In the diagram, we should take as the left hand corner of the given figure origin. Then entire figure lies in the first quadrant. Now, the third one is subdivide the given figure into non-geometrical sections and identify the individual centroids by denoting them with C, where are the I number of the subdivided shapes. Okay, here the third segment is subdividing the figure into non-geometrical. Example, we have a center semicircle. Let us imagine that it's containing two parts, like upper curve is a semicircle and bottom is like rectangle. Then it becomes two geometrical figures. Like the third statement is implies that type of problems. Now last one is fourth point is entering the values into table columns as shown below. Here we can observe that component area and central distance from y-axis and central distance from x-axis and ax, ay and summation of ax and summation of ay and sum equal. This is the component we should have to draw the before we are solving the problem. The fifth one is indicating the calculations like enter x into y values for the area and then the result do not enter result directly from central distance. Entering the equation with the substituted numerical values like 3 plus 4 into 5 by 3 by. The areas are negative if all and centroid values are negative if they are below the x-axis or left the y-axis. It defines that the calculations like x into y values for area and for values for x and y for area. Then enter the result, not enter. We should not enter the direct length result for centroid and distance. Entering the equation with the substituted numerical values like 3 plus into 4 into 5 by 3 by. The areas are negative. If the areas are negative, it follow the centroidal values are negative if they are below the axis of the left y-axis. Compute the centroidal values as x bar and y bar. Inform x bar and summation of ax by summation of a. Summation in y bar similarly summation of ay by summation of a. Now coming to seventh point, the centroidal value of a triangle is always 1 by third length and that from the base 2 by third length from the height from the apex. The centroidal triangle is always one third in the length from the base of a triangle and it depends on the height of the apex. This is all about the seventh point. And the eighth one is the centroidal of a semicircle is always measured from 4 or by 3 by from the base of the semicircle normal to the base along symmetrical axis. Similarly, some problems like symmetrical axis are usually depends on the measuring the values from the base of the figure. Now, this is all about the tips to solve problems on central. Let us move to the example now. Determine the position of the centroid of the area shown in the figure. Okay, and you can see the figure in this here. This is like a component solutions, and this is that fourth point implies that here component area x, y, x, and ay. Let's look at the figure. This is first, and this is second, and this is third, and this is here first one is triangle. Okay, we can see that this part is there no 50 mm like in this okay, this is called triangle and second one is this is called rectangle. Okay, you can see between 2 and 5 and 3 is component. This is called rectangle and the third one is in above. This is called rectangle. This is called triangle. Sorry, this is also a second triangle in the figure. And now fourth one is this is quarter circle. Means circle only little tilt is for six. And fifth one is semicircle. We can clearly see that we are above 100 millimeter. This is semicircle. Now let us compound. Let us find solutions. Now this component area x, y, ax, and a. Triangle and rectangle, quarter circle, semicircle, and circle. Let's area. Area of the triangle is half into base half here and half into base into height. Base means 50 and height means 60. Okay, 60 is there. So 50 into 60, 1500. Rectangle similarly 200 into 60. It's 2 b to d 200 and 60 1000. Half into 200 into 88,000. Now quarter circle pi into 60 square by 4. 2827.43 pi semicircle pi into 50 square by 3926.99 summation of a 20.400 442. Now similarly x is equal to 2 by 3 into 50 means so x value to find the figure. 2 into 3 2 by 3 into 50 means similar 33 point something 53 will be the answers. And similar as of rectangle, so 20 by 2 plus d by 2 is 50. D means 200. Okay, d by 2 means 200 by 2 is 100. 100 plus 50 is 150. Similarly here also d by 2 100 plus 50 150. 4 into 60 by 3 by plus 250. We know the 4 into 60, 240 plus the 3 into 5 into 22 by 7. We can find plus 250. Somehow the value is 275.465. Similarly, 100 by 2 plus 100 is equal to 150. 1 by 3 now in by value. 1 by 3 into 60 means 1 by 3 take 2 okay 20. 60 by 2 it is 30. 60 plus 80 by 3 86.667. 4 into 60 by 3 by 25.465. 4 into 50 by 3 by 21.2. Now some AX triangle means 49.9. Okay, rectangle is 1.88. Now triangle is 1.200. Okay. Now quarter circle is 778.85. Your summation of AX means this you have to multiply with this one. This will we get answer like this 49. Similar rectangle, triangle, like quarter circle. Now semicircle is like this. Semicircle answer AX is 589 minus 589.048.65. Summation of AY first we have to 1500 into 40. This 30,000 something. 3 seconds rectangle is 360 something, and the third triangle 693 and quarter circle 72,000 by minus 83 point. Now total we have summation of AX means 3.2398068, summation of AY 1.0720013905. X bar is equal to summation of AX by summation of A. Like a summation of X bar answer is 158.81 meter, and similarly Y bar is equal to summation of AY by summation of A. 172.001.905 divided by 20,400 divided by 0.442, 52.548 millimeter. So this is all about the example position from center of the question figure. I hope you understand this problem. I hope you watching my video till the end, and thank you for watching the video. Yeah, thank you.